To an example in which we are looking at, says, suppose you're offered the following deal. You roll a six-sided die. If you roll a six, you win $6. If you roll a four or five, you win $4. Otherwise, you pay $5. What do you think about that? The casinos had a new game like that. You roll a die, or your shady friend says, hey, let's play this game. You roll a six-sided die. If you get a six, you're going to win $6. That's nice. If you roll a four or five, you're going to win $4. But if you otherwise, meaning one, two, or three, you're going to pay $5. What do you think about that? Is that a winning game specifically? Is that a game you should play and you'll win? Well, first thing it says is complete the PDF tail, which means probability distribution table. List the X values where X is the profit from smallest to largest. Okay, so see what it says here. This is the profit, right? So right there, X is the profit. And then P over here is the probability. And see how it said smallest to largest. So this is small, medium, and large dollars. Profit, right? That's what they said. Smallest to largest. Okay. So what's the smallest, lowest, worst thing that can happen to you financially? Well, you can pay $5. So that's why this is -5, as you see right there. Right? If you roll, and otherwise means if you roll, if you roll one, two, or three, then you pay $5, right? Next, the medium thing is if you roll a four or five, you win four. So that's +4, as you see right there. If you roll four or five, and then the best thing, if you roll a six, you win six. So that's you can win $6. Okay, so see what I'm doing. I listed X, the profits. They said it right here. X is the profits from smallest profit to largest. Smallest is you could lose $5. Medium is you can win four, +4. Best is you can win six, +6. So losing is negative, obviously, right? Affects your bank account negatively. Winning is positive. Okay. Now, what are the probabilities of those things? What's the chance they're going to happen? What's the chance, first off, that you're going to lose $5? Well, how do you lose $5? It says if you roll a six, you're going to win $6. If you roll a four or five, you're going to win four. So there's six numbers, right? One, two, three, four, five, six. It's going to be one of those six numbers. So if you roll a six, that's a win plus $6. If you roll a four or five, you're going to win plus $4. So what's left? One, two, and three. You're going to lose or pay what? $5. So -5. All right. So what's the chance that you're going to do that? You're going to lose and pay $5. Well, it's if you roll a one, two, or three. Well, that's 3 out of 6. So this is 3 out of 6. That's the probability, excuse me, that you're going to lose and pay $5. 3 out of 6. See what I'm doing there? 3 divided, and you can put a fraction in or the decimal 0.5. It'll take it either way. I checked it. Next thing, so that's if you, oops, that's to lose $5, right? Next, how do you gain $4? Well, win $4 if you roll 4 or 5. So that's 2 out of the 6 different things that can happen. And again, you can do the decimal or the fraction. It takes either one. And then the best thing that can happen is you can win $6, win $6. That's just getting a 6. That's only 1 out of 6 is the probability of that, or you can put in the decimal. Okay, now final and well, not final, but really important question. Find the expected profit. So like in the end, what are you going to win or lose? What do you expect on average to happen as you play this game? You're going to win. I mean, you can, of course, you can lose, you can win. What's going to happen on average? That's what expected profit is. It's the average result you expect to happen. Now, that's in the notes. Let me show you in case you're not clear on that. So here I'm on the course homepage. Click on notes, and I'll just open it up right there. Unit 2, notes, come on down. Here we are. We're gambling or insurance. That's our section. So is there a cost or is there no cost? Well, on this problem, they never said it, what that it costs a certain amount to play the game. So we're looking at this no cost situation. Sometimes with the casino games, they'll say it's, $3 to play this game and then da 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 da. They didn't say that here. They never mentioned it. You can lose money or win money, but they never mentioned a cost. Okay, so we're in this section. There's no cost. If the problem says expected value for you, is that us? Yeah, it did. It said, what's your expected? It didn't say you, but it's implied. What is your expected profit? It's not the company. It certainly didn't say the company. So we're right here. The problem says expected value for you. What do? You add up each winning positive or losing negative multiplied by the probability. So you add up each of those dollar amounts times the probability. Okay. We can do that. Let's go back to it. So I'm going to take this dollar amount minus 5 times the probability 0.5 plus, going to add up 4 times 0.3333. That's enough. Plus 6 times this 0.1666. It's plenty right there. And then hit equals or enter or whatever works on your calculator. See, I'm following the instructions. I'm multiplying, as it said in the notes, each dollar amount times the probability. You can do the fractions if you prefer. Dollar amount times probability, dollar amount times probability, dollar amount times probability, and then adding them up. So minus 5 times 0.5 plus this times this plus this times this equals. And when you do, you'll get this answer. It'll actually come out negative 0.1666 forever, which rounds it to the nearest penny, right? You remember how we round? We just circle right there. That's the pennies place. Look to the right. That's 5 or more. So negative 0.17, which you see right there. In other words, what does that mean? Expected profit. We expect, on average, to lose 17 cents. It's negative, so we're going to lose 17 cents. That's the average that we expect. Excuse me. And then coming on down. So what does that mean then? Interpret the expected value. Well, it's right here. If you play many games, you will likely lose on average very close to 17 cents per game. Right? Because you might wonder, you can't lose 17 cents. That's true. Not in any one turn. You're either going to lose $5 or gain $4 or gain 6. You're not going to lose 17 cents. Right? But that's the average. That's what expected value means. That means if you play lots and lots and lots of times, the average will come out like you're losing 17 cents every time you play. Based on this expected value, should you play this game? No. Since the expected value is negative, you would very likely come home with less money than you started. Right? Expected value right there. Yeah, you're going to lose money. On average, if the expected value is negative, that means you expect, on average, to lose money. And so, there we go.